Today we're going to take a look at trig ratios. And so we're going to review SOHCAHTOA. So if we have sine of theta, that's going to be equal to opposite over hypotenuse. And then if we have cosine of theta, that's going to be equal to adjacent over hypotenuse. And then if we have tangent of theta, that's going to be equal to opposite over adjacent. And so if we draw ourselves a little right triangle picture, where this is theta, this is A, B, and C. From theta, the opposite side is across from your angle theta. The adjacent side is right next door to your theta, but not next door and the hypotenuse, because your hypotenuse is opposite of your right angle. So now we're going to look at the reciprocal functions for each of these. And so if we want the reciprocal function for sine, so 1 over sine of theta, that's going to equal to cosecant of theta, which is going to take the reciprocal of our fraction for sine, which sine is opposite over hypotenuse, so the reciprocal is hypotenuse over opposite. And then if we do the reciprocal for cosine, so it's 1 over cosine, that's going to be secant of theta, and that's going to be the reciprocal of our cosine fraction, so this is going to be hypotenuse over adjacent. And then the reciprocal for tangent would be 1 over tangent of theta, and so that's going to be cotangent of theta, and so that's going to give us adjacent over opposite. And so I remember these because sine starts with S, and so the reciprocal starts with C. Cosine starts with C, the reciprocal starts with S. And then tangent makes sense because it goes with cotangent. So if we go on and do an example, where we're given this triangle, we want to find all 6 trig functions for this triangle. So that means we need to find sine of theta, cosine of theta, tangent of theta, and then we also need to find cosecant of theta, secant of theta, and cotangent of theta. Actually, I'm going to write these 3 below just so it gives me more room to work. So if we start by labeling our triangle, so from theta, opposite of theta is side 2, so I'm going to label that for opposite. Adjacent is right next door here at square root of 5. And then hypotenuse is opposite of our right angle, so that's up at 3. And so sine is opposite over hypotenuse, so that's going to be 2 over 3. And that cannot be simplified in any way, so we're done with that one. Now cosine of theta is adjacent over hypotenuse, so it's square root of 5 over 3. And again, that cannot be simplified, so we're done with that one. And then tangent is opposite over adjacent, so it's going to be 2 over the square root of 5. But if you remember from yesterday's notes, you cannot leave a radical in your denominator. So we have this square root of 5 here, which means that we need to rationalize this denominator. So we're going to multiply by the square root of 5 over the square root of 5. So then we do numerator times numerator, so 2 times the square root of 5 over square root of 5 times the square root of 5, which is the square root of 5 squared. The squared cancels with the square root. And so that gives us 2 square root of 5 over 5 as our final answer for that. Now if we keep going to our reciprocal functions, we have cosecant of theta. Cosecant of theta is the reciprocal of sine. And so we're going to take the 2/3 that is sine and we're going to do the reciprocal of that. So it's going to be 3/2. Secant is the reciprocal of cosine, so we're going to take the square root of 5 over 3 of cosine and do the reciprocal, which gives us 3 over the square root of 5. But now we run into the problem where the square root of 5 is in our denominator, so we need to rationalize that denominator. And so when we do that, we get 3 times the square root of 5 over the square root of 5 squared. And again, those cancel. So it ends up giving us 3 square root of 5 over 5 as our final answer for that. And now we go to cotangent of theta. So when we do cotangent of theta, even though we go back to tangent of theta, which is cotangent is the reciprocal of, we want to use the very original fraction that we started with for tangent. And so we're going to take the reciprocal of that, which would give us then the square root of 5 over 2. Last example is finding a missing side. And so for finding a missing side, if you have the example where you're given the triangle and your angle is 30 degrees, then you have 3 and you're trying to find x. You want to note that this is the opposite side and this is your adjacent side. And so if we think of SOHCAHTOA, tangent, because TOA is what uses our opposite and adjacent sides, so we're going to say that the tangent of 30 degrees is equal to our opposite side over our adjacent side. We're going to think of tangent of 30 as over 1, and then this is now a proportion, and we can cross multiply. And so we get x times the tangent of 30 equals 3. And now we can divide each side by the tangent of 30. And so that gives us x equals 3 over the tangent of 30. And you're going to put this in your calculator and make sure your calculator's in degree mode. And you're going to get that it's approximately 5.2.